4. 4 cannot be referred to as surds because you can break this down into 2. So you can break this down into 2. But when you have 2, square root of 2, it will be in decimal fraction. That'll be around 1.414. 11. This cannot be broken into 2 factors of any other digit. So this is just a simple introduction about sort. Sort are numbers which are roots of irrational numbers. So I'll move to rules of sorts. Rules of sorts. That is, there are rules that guide sorts. The first rule says that if you have a square root of 2 digits, say m and n, square root of m times n, the rule says that this is same thing as square root of m multiplied by square root of n. That is, if you have the square root of the product of 2 numbers, it can be splitted as we have it on the board. E.g., e.g., let's say we have the square root of 9 times 16. So it is possible to split this to say square root of 9 multiplied by square root of 16. So square root of 9 is 3 times square root of 16 is 4. So we get 12. And of course, if you don't want to do it that way, you might decide to first multiply 9 times 16. That gives 144. Then the square root of 144 is 12. So under the rules of sort, multiplication can actually be splitted. Then the second rule says that if you have square root of m divided by n, the rule says that you can break it down to square root of m, then all over square root of n. That is, it is allowed. You can split it like that. So let me just give example of this second rule. E.g., when we say we have square root of say 16 all over 9, you can split this to square root of 16 divided by square root of 9. So it is allowed. The square root of 16 is 4 all over 3, and that is what we get. So we can do it that way. But square root of a plus or minus b, I will explain, is not equal to square root of a plus or minus square root of b. What am I saying in essence? When you have multiplication, I said it can be splitted. When you have the same thing, but when you now have addition and subtraction, you cannot break this down. That is, e.g., we cannot say that square root of 4 plus 9 is equal to square root of 4 plus square root of 9. Addition does not hold because square root of 4 plus 9 will be square root of 13, which is not the same thing as square root of 4 is 2 plus 3, and that is 5. Square root of 13 is less than 4. Whereas if you split it like this, you are going to get 5. So this rule does not hold for addition and subtraction. That's why I said square root of a plus b plus or minus b. So either addition or subtraction. Let's take note that you cannot apply the rules when we have addition and subtraction, but when we have multiplication and division, those operations can be splitted. So I will now introduce the basic form of sorts. Basic forms of sorts. So square root of n in its basic form is in its basic form if n does not contain a factor which is a perfect square. That is, this square root of n is in its basic form if this n cannot be broken down to have one number then a perfect square. E.g., e.g., when we have e.g., when we have square root of 5, it is not possible to break this down into 2 different factors. We cannot do this because these are prime numbers. Another one is when you have square root of 11, square root of 13. We cannot break those ones down into 2 different digits. So once we have something like that, then that sort is in its basic form. So that's the basic form of that sort and cannot be simplified further. So if you have sort in its basic form, it cannot be simplified further. So let's give example. Let's say example 1. Example, say simplify a square root of 75. Let's just take two examples just to buttress our point. Then square root of, let's say, 80. In this case now, what do we do? The first one is square root of 75. 75 cannot be said to be in its basic form because we can actually split this down into two, in which one of the digits that we are going to get here can be called a perfect square. When do you refer to a number as a perfect square? If the square of that number and the square root of that number gives a whole number, then we call such a number a perfect square. Then what am I saying in essence? I can break this down into two. I can say this is the same thing as 25 multiplied by 3. 25 is a perfect square. Why is it a perfect square? Because the square root of 25 is 5. And the square of 25 is 625. So the two gives a whole number. So if you have to simplify or to reduce a sort to its basic form, just try and split or break what you are given down into two, in which one will be perfect square, then the other can be can be ordinary digit that cannot be splitted. So in this case now, I can change this to square root of 25 times square root of 3. Square root of 25 is 5, then multiply by root 3. Of course, you can write it together to get 5 square root of 3. And that is, we have simplified this 75 to its basic form. This sort is root 75. The basic form of root 75 is 5 root 3. And you can be given sort in basic form and, and be asked to convert it back to root 75. Is vice versa. Then the second example, that second example is when we have square root of 80. Of course, what can we do here? We can also split this one down into two. That is, if you want to do that, you think of a number cannot be reduced and a number that can be reduced, which most often time is always a perfect square. I can say 16 times 5 because the square of 16 will give a whole number and the square root of 16 will also give us a whole number. So that will now be 16 multiplied by square root of 5. What's square root of 16? It is 4. Then multiple root 5. So we cannot break this one further. Then we say square root of 80 is same thing as 4 square root of root 5. So we have been able to convert square root of 75 and 80 to their basic form, as we have seen in that example. Then I would quickly talk about what is called the similar sorts. Similar sorts. From that word similar, it is so sort in the same basic form can be added or subtracted. When it comes to only add or subtract some sorts that are similar. That is what we are trying to see here. You can only add or subtract sorts that are similar. For instance, you cannot add 2 plus 3 and say this is 5. It is not possible because they don't have anything in common. They are not similar. So you can't do this. This is wrong. This is wrong. But we can add, say, square root of 3 plus 2 square root of 3. So these are similar sorts because they have something in common. Of course, this square root of 3, there's one here, imaginary one here. So 1 plus 2, it will be 3. Then we can add this to be 3 root 3. Do we understand that? So we can only add or subtract similar sorts, sorts that have something in common. That is what we can do. So once we reduce a sort to its basic form, so sort in its basic form can be added or subtracted from each other. So let me just give one or two examples under this similar sorts. Under the similar sort, let's say let's say example 2. Simplify. If you are asked to simplify the following, what we have on the board, then the first one is where we have square root of 50 minus square root of 18 plus square root of 32. So if you are given something like this now, you have to think on how to break all this down to their basic form. Then we not take it from there. Square root of 20 plus square root of 45 plus square root of 125 minus 2 square root of 80. Okay, so now let's look at what we have on the board. The first one, we have square root of 50 plus square root of 18 no, minus square root of 18, then plus square root of 32. If we look at this critically, what can we say about it? You realize that something like 2 can come out. Something like square root of 2 can come out in each of these, where we split each to 2 factors. For instance, this first one now, I can split this to 25 multiplied by 2, which is 50. This second one also, I can split it to 9 times 2, because when I split this, one of these factor now has become a perfect square, because the square and the square root of this is going to give me a whole number. In this case also, I decided to split this into 2. This factor square. Why is it a perfect square? Because the square and the square root will give a whole number. Then the last one, I can split this also to 16 multiplied by 2. Okay. Then I can do this straight away, because I know if I have product of two sorts, it can be splitted to the square root of the first one and the second one. That is rule one. So in this case, now I don't want to waste. I don't want to waste time. What square root of 25 is 5? So I can change this to 5 root 2 minus what square root of 9? 3. I can change this to 3 root 2. Then plus what square root of 16? That is 4. I will change this to 4 root 2. At this point now, we realize that these sorts are similar. This is root 2, this is root 2, this is root 2. Then we can add or subtract similar sorts. 4 plus 5, that is 9. So I will have 9 root 2 minus 3 root 2. And that is going to give us 6 root 2. And that is what we are expected to get. So this is what we are expected to get in this case. So if you ask to simplify this type of problem, the first thing to do is to reduce each to its basic form. Then now look at the ones that are similar, because we can only add or subtract similar sorts. So we have been able to solve the first example. So I can go ahead and solve the second one. This second one, if I want to do that, it's still the same process. Look at, it's like something is common here, because this is 5, this is 5, 5, they are divisible by 5. Then this one can also is also divisible by 5. Then of course 20 also 5 can divide that. So I'll just say this is 4 times 5 plus, I can change this to 9 times 5 plus, I can change this to 25 times 5 minus 2 is there already. Then I can change this to 16 times 5. So what is square root of 4? It is 2. So this automatically becomes 2 square root of 5 plus this will be 3 square root of 5 plus this will be 5 square root of 5 minus 2. This is outside the square root. So what is square root of 16? 4. That will be 2 times 4 square root of 5. So what do I have here? Of course, they are similar sort, because square root of 5 is common to everything. So 2 plus 2, 2 plus 3. So 2 plus 3 is 5. 5 plus 5 is 10. Then I will have 10 square root of 5 minus 2 times 4, 8 square root of 5. So from here now, I'm going to get 10 minus 8. It is 2. So this will be 2 square root of 5. And that will be the final answer that we have. So I want us to note something. Let's note. I want us to note something. Let's note that mixed, mixed swords, such as, such as 3 square root of 2 plus 2 square root of 3 cannot cannot be simplified, cannot be simplified further. What do I mean by that? Look at this now. In the first one, we have square root of 2. In the second one, we have square root of 3. They are not similar. So let's say we are given a particular problem, either in algebra or trig, and you were working, you are trying to solve the problem, and you arrive at something like this. This is how you are going to leave your final answer, because they are not similar. You cannot say this is equal to 3 plus 2, 5, and square root of 2 plus square root of 3 is square root of 5. No, we can only add or subtract similar sorts. So please let us note that. Let's note that. that you can either add or subtract similar sorts. That is what we can do. Then there's this other concept that I would love to introduce, and it is called the conjugate. Conjugate sorts. Conjugate sorts. Conjugate sorts. Of course, why do we need the knowledge of conjugates? Conjugate sort. You know, when we have a sort in its sort in form of fraction, and if we have square roots at the denominator, for instance, if you have something of this nature, let's say you have 2 divided by root 3. Of course, in mathematics, it is not proper to leave square roots at the denominator. What we normally do is that we rationalize. We multiply both the numerator and the denominator by this root 3. At the end of the day, we are going to have 2 root 3. Root 3 times root 3 is root 9. What is root 9? 3. So it is proper to leave your answer in this form rather than leaving this answer in this form. And of course, if you use your calculator to check this 2 divided by root 3 and 2 root 3 divided by 3, we are going to get the same answer. But what if, what if the denominator of this fractional sort has either addition or subtraction? For instance, if you have something like 1 all over square root of 2 plus 3, something like this, how do you simplify this? Then the concept of conjugate sort comes in, because if you want to rationalize this now, what we normally do is that we use the conjugate of this sort to multiply both the numerator and the denominator. So let me go back to conjugate sort. So let me go back to conjugate sort. If we have this expression, let's say we are given this expression, square root of a plus square root of b. If this is what we are given, then then square root of a minus square root of b is called the conjugate. Conju conjugate is called the conjugate of square root of a plus square root of b. That is, if you have a sort, the conjugate of that sort is just to change the sign. If what you are given is negative, then the conjugate becomes positive. And if what you are given is positive, the conjugate becomes negative. That is all about conjugate sort. So if you are to find the conjugate of a sort, just change the sign from plus to minus. Then also note that the product of a sort and its conjugate give a rational number. That is, when you use a sort to multiply its conjugate, we are not going to get a sordic form again. We are going to get a rational number. For instance, if I use square root of a plus square root of b to multiply square root of a minus square root of b, what we are saying in essence is that I'm going to get a rational number. I'll get a number that does not have square roots. That is, let's do this. Square root of a times square root of a will be a, because the square root will take care of the square root. Then minus square root of ab plus square root of minus square root of ab plus square root of ab, then minus b. You realize that what we have inside will cancel out. At the end of the day, we are going to get a minus b. And that's what we are trying to say. That when you use a sort to multiply its conjugate, if you use a sort to multiply its conjugate, then the final answer must give us a rational number, a number that does not have square root. Let's just take maybe 2 examples under conjugate sort. So let's say you are given, you can be asked to find the conjugate. Just say find the conjugate, or write down the conjugate of the following sorts. So let's say a you are given square root of 3 minus square root of 2. Then b, the other one, we are given 2 square root of 5 plus 3 square root of 3. So if this is what we are given, and you are asked to find the conjugate, you don't need any calculation. The first one is that if you are given root 3 minus root 2, the conjugate will be root 3 plus root 2. Just change the sign. That is the meaning of conjugate. Then the second one, if you are given 2 root 5 plus 3 root 3, its conjugate will be 2 root 5 minus 3 root 3. That is just the conjugate. We don't need to do any stress. Okay. Then, as I've said earlier on, the knowledge of conjugates is needed in sorts because of the concept that is referred to as rationalization. Rationalizing the denominator, that is at times in sorts. If you have a question in form of fractions, then how do you simplify? Most often time, we use the conjugate of the denominator to multiply both the numerator and the denominator. So the next concept can be referred to as rationalization. Rationalization. Is that I call it rationalization? Or we can say it can be called we can be referred to as rationalizing the denominator. That is, if you have, let's say we have, if you are given something like this, like we are given 2 divided by root 3. So how can we write this in a convenient form? I think I've explained something like this earlier on. If you have 2 divided by 3, how can we write this in a convenient form? To be able to write this in a convenient form, this is what we do. We multiply both the numerator and the denominator by the conjugate of this. No, in this case now, no conjugate because it's just a single sort. Then this will now be 2 times this. I have 2 root 3 all over square root of 3 over square root of 3. That's square root of 9, and square root of 9 is 3. This is how to write this concept in a convenient form. We have something like addition or subtraction at the denominator. What do we do? Let's say we have addition or subtraction at the denominator. What do we do? For instance, if you have something like 1 all over square root of 2 plus 1, if this is what we are given, then what do we do? How do we rationalize this? The only way to rationalize this is to multiply both the numerator and the denominator by the conjugate of this denominator. And what is the conjugate of this denominator? That will be square root of 2 minus 1. If you have it to be positive, its conjugate will be negative. And if you are given a negative value, its conjugate will be positive. It's vice versa. So you multiply both numerator and denominator with the conjugate of what we are given. So if we want to multiply the numerator, we are still going to maintain our square root of 2 minus 1 all over. In this case now, you have square root of 2 times square root of 2, and that is 2. That is 2 because it will be square root of 4. What's square root of 4? Square root of 4 is 2. Square root of 2 times minus 1 is minus square root of 2. Square root of 1 times square root of 2 plus square root of 2. Then minus 1 times plus 1 minus 1. This will cancel out. Please note, under rationalization, when you check the denominator, you don't need to waste your time. This is the shorter way to go about this, because this is a sort and this is the conjugate of that sort. Just square the first one. Just take the square of the first one. This is what you are expected to do. Take the square of the first one, root 2 all squared, minus the square of the second one, 1. So square will cancel square root. You have 2 minus square root of 1 is 1. At the end of the day, you're going to get 1. When we decide to simplify, to open it up, what do we have at the end of the day? We have square root of 2 minus 1 all over 2 minus 1, 1. And the final answer is square root of 2 minus 1. So at the denominator, you don't need to stress yourself. You don't need to go through all this process. What is expected is that you square the first one minus the square of the second one. That is what we are going to get at the final answer at the denominator. But of course, at the numerator, go ahead and do whatever is expected of you. So I will give 1 or 2 examples under rationalizing the denominator. So I'll give 1 or 2 examples under rationalizing the denominator. So I can say example, let's say example 4. I will say simplify 2 all over square root of 5 minus square root of 3. If this is what we are given, then what are we expected to do here? If this is what we are given, what are we expected to get here? So that's what I'm about to do now. So in this case now, we have 2 all over square root of 5 minus square root of 3. So for us to be able to simplify this, we are going to multiply the numerator and the denominator by the conjugate of this denominator. And the conjugate of the denominator simply means just change the sign from minus to plus. So I will have square root of 5 plus square root of 3 all over square root of 5 plus square root of 3. So at the denominator, 2 is going to multiply everything that you have square root of 5 plus square root of 3. Okay? So at the denominator, what are we expected to do? The shorter form is that just square the first one. Take the square of the first one, that will be 5 because square we can square root, minus take the square of the second one, square we can square root 3. At the end of the day, we are going to have 2 square root of 5 plus square root of 3 all over 5 minus 3 is 2. 2 will take care of 2. Then the final answer will be square root of 5 plus square root of 3. Look at these are not similar sorts. So you cannot add it and say, this is square root of 8. No, this is wrong. You cannot add this. You can only add or subtract similar sorts as we have discussed. So this is the final answer. Just leave it like that. You cannot add square root of 5 plus square root of 3. You cannot do that. So this is what you are supposed to do. This is how you are supposed to leave the answer. Then let's take another example. I'll take, let's say, the last example under rationalization before I will introduce equality of sort. So simplify. What do we want to simplify? We want to simplify 1 all over root, root 5 minus root 3, then minus 1 all over root 5 plus root 3. Of course, you can have you can have problem in this form. So if you have problem in this form, how do you approach it? How do you approach this type of problem? Of course, before you can do anything, in this case now, the first thing to do is to find the LCM. You find the LCM, which is square root of 5 minus square root of 3, multiplying square root of 5 plus square root of 3. So this in this, we are going to get this. I will have square root of 5 plus square root of 3 minus this in this, we are going to get this square root of 5 minus square root of 3. And that's what we are going to get. So if we open up, let's open the numerator. We have 5 square root of 5 plus square root of 3 minus this will be minus square root of 5 plus square root of 3. Minus times minus will be over. This is sort, this is conjugate. If you open up, you have 5. That will be 5 minus 3. Because when you use this to multiply this, you get 5. This to multiply this root 15 minus root 15 will cancel out. So this is what you get. Then at the numerator also, root 5 can take care of root 5. So that at the end of the day, we have 2 root 3 all over 2. 2 will cancel 2. So that our final answer will not be square root of 3. And that is what we are expected to get. So that is what we are expected to get. That's what we are expected to get. So I would love to introduce equality of sorts. Equality of sorts. Equality. Equality. Equality of sorts. Equality of sorts. Two expressions in sordic form are said to be equal if, for instance, when you have two expressions like a plus square root of b and c plus square root of d, these two expressions, this and this, are said to be equal if a is equal to c and b is equal to d. The only way for these two expressions to be equal is when a is equal to c and b is equal to d. That is the condition. So the concept of equality of two sorts enables us to determine the square root of a sordic number. That is, this concept, this idea now enables us to be able to determine the square root of a sordic number. That is, if you are asked to find the, if we are asked to find the square root of if you are asked to find the square root of a sort, the concept of equality will help us to be able to do that. Example, Let's example 6 or 7. 6. Let's example 6. Find, the question says find the square roots. Find the square roots of, what are we given? 3 plus 2 root 2. We have to find the square root of this 3 plus 2 root 2. So how do we go about this? How do we find the square root of this? But from this our knowledge now that if you have this type of sort, these two expression, this two expression will be equal. If this first one, A, is equal to A, and the one inside the bracket is also equal, you equate it, then we say that these two expressions are equal. So in this case now, this is what we are asked to find. So how do we go about this? We use the let statement. We can say let, we have to find, we are asked to find the square root of 3 plus 2 root 2. We now say let the square root, let the square root, let the square root of 3 plus 2 root 2 be, let's say, square root of p plus square root of q. Let's just use that. We don't know the square root, but we assume it to be square root of p plus square root of q. That is the assumption. So if that is the statement, then what is the meaning of this? Then we now say that 3 plus 2 root 2 can now be equal to square root of p plus square root of q all squared, because we have we decide to represent the square root of this to be this. Then so that I'm going to get square root of p plus square root of q multiplied by square root of p plus square root of q. So if I open up, I'm going to get p. I will have square root of pq plus square root of pq plus square root of q. Then at the end of the day, I'm going to have p plus q plus 2 square root of pq. That's what we are going to get, being equal to 3 plus 2 root 2. So that is what we are going to get. Then what do we do? From the knowledge equality of sort, we know that this and this are equal if p plus q is equal to 3 and square root of pq is equal to 2. That is what we know. So we now say from equality, from equality, from equality of two sorts, from equality of two sorts, we have that p plus q is equal to 3. That is the first one. We can maybe call that equation 1. That's what the first thing that we have. We also have that 2 square root of pq will be equal to 2 square root of 2. If we divide both sides, this is equation 2. So this is equation 2. So from equation 2, we can divide both sides by, from equation 2, from the second equation, we can say 2 root 2 pq divided by 2 is equal to 2 root 2 divided by 2. So 2 will cancel this will cancel this. And of course, square root can take care of square root. Square root can take care of square root. So if square root takes care of square roots, what do we have? We now have pq to be equal to 2. Let's call that one equation 3. So there are two equations now. Pq equal to 2 and p plus q is equal to 3, equation 1. So there are two equations with two variables. Of course, we can only solve this using simultaneous equation, because the two equations are simultaneous, two equations with two variables. So we either use substitution method or we use elimination method. Then from what I have now, I can say from equation 3, I can make p the subject of formula so that p will be equal to 3 minus q. Let's call that one equation 4. Then I can now substitute p is equal to 3 minus q into equation 3. If I do that, initially I have pq to be equal to 2. What is p now? P now is now equal to 3 minus q. Multiplying q is equal to 2. If I open up, I'm going to get 3q minus q squared is equal to 2. And of course, I can bring everything to the right hand side so that I'm going to get q squared minus 3q plus 2 equal to 0. So I've gotten a quadratic equation. And once I have quadratic equation, and this type of quadratic equation is factorizable, so I can go ahead and factorize this. So I'm going to have q squared minus 2q minus q plus 2 equal to 0. Then let's look for what is common. This is q. We have q minus 2. What is common here is minus 1. I have q minus 2 equal to 0. So from this point now, this is what is expected. So what you have here is what I have here in the same bracket. So I'll combine these two to have q minus 1 into bracket q minus 2 equal to 0. And this simply means that q minus 1 equals 0 or q minus 2 equals to 0. So q is equal to 1 or 2 of q that we have. So since we have gotten the value of q, then we can recall. We have gotten the value of q. We can now recall. We can recall that p is equal to 3 minus q. So when q is equal to 1, what is p? P will be 3 minus 1, and that is 2. Then when p is equal to 2, when q is equal to 2, then we know that p minus is equal to 3 minus 2, and that is equal to 1. So what we have now, so we have p when p is equal to 1, q is equal to 2, and when p is equal to 2, q is equal to 1. So we can now go ahead. From there now, we can go ahead to substitute the value into what we our initial assumption. No, we now say hence the square root of 3 plus 2 root 2 are, we assume it to be square root of p plus q. So when p is equal to 1, q is equal to 2, there will be, this is what we have. When p is equal to 1, square root of 1 is 1. 1 plus square root of 2, or square root of 2 plus 1. And that is what we are going to get. So it simply means that since it's addition, I can rewrite the 2. So that's square root of 2 plus 1 twice. That will be the square root. That will be the square root of that question. That will be the square root of that question. Then over time, who loved the last concept under, and that last concept is called equations in irrational form. Irrational form. Equations in irrational forms. Of course, we might have of equation on several occasions. We know that the concepts sorts come into being because of irrational numbers. Had it been we don't have irrational numbers, there won't be anything called sorts. We have the concept sorts because of irrational numbers. So in this case now, how do we approach equations that involved irrational that has irrational form? I will just use this example to explain. Let's say example 7 thereabouts. When we have solve the equation, which equation square root of 4x minus 1 plus square root of 2x minus 3 is equal to 4. Look at this equation very well. This is what we are given. So this is a typical example of equation that has a rational form. So how do we solve this? Of course, we can't just solve this directly. What do? We have to approach this stepwisely. So you know that for me to be able to solve this problem, I must eradicate this square root. I must remove this square root there. Then what can I do, or what can be done so that this square root can be removed? what first comes to my mind is square, because square can actually take care of square root. So I will say take the square, I'll say take the square of both sides. That is, I will have square root of 4x plus 1 plus square root of 2x minus 3 all squared is equal to 4 squared. That is the first step that I'm going to do. And if this is what I have, then what is the next step? So I will open up. I'm going to open up what I have here. That is, I'm going to have square root of 4x plus 1 multiply square root of 4x plus 1 plus square root of 2x minus 3 multiplied by square root of 4x plus 1 plus square root of 2x minus 3. Everything is equal to 16, because when I take the square of this, I'm going to get 16. So I'm going to expand this now. If I expand this now, this times this, square root will take care of square root. I'm going to have 4x plus 1. Just like when you have square root of 2 times square root of 2. This is square root of 4. Then what's square root of 4? It's not 2. It simply means that when you have square root of the same thing, just let the square root take care of each other and take just one of the value. So that is what will happen. So that's what we have. Then this times this second one, I'm going to have plus into bracket square root of 4x plus 1 multiplied by 2x minus 3. So if I use this to multiply this again, I'll get the same thing. So that can attract 2 here. Then lastly, I will have plus 2x minus 3 when this multiply this to be equal to 16. So I can rearrange 4x plus 2x is going to give me 6x minus 2, then plus 2 square root of, I can open up here to get 8x squared minus 12x plus that will be minus 10x, then minus 3. That's what I'm going to have when I open up what I have here is equal to 16. So that's equal I'm going to have that to be equal to 16. Okay. Then I want to transfer everything. I will leave 2 square root of 8x squared minus 10x minus 3 to be equal to, I will transfer everything here. I have 16. Initially, we have minus 2 here. By the time this minus 2 crosses this equality sign, it changes to plus. So I have plus 2 minus 6x. So, and this is the same thing as 16 plus 2 is 18 minus 6x. Then this is 2 square root of 8x squared minus 10x minus 3. I can divide both sides by 2. 2 can divide this. 2 we can take care of 2 here. Then in this case now, what we can have is that to bring out 2 so that we have 9 minus 3x all over 2. So 2 will cancel 2. 2 will cancel 2 there. So 2 will cancel 2. So we are left with square root of 8x squared minus 10x minus 3 being equal to 9 minus 3x. So I can take the square of both sides now. Take the square of both sides. If I do that, then I'm going to have square root of 8x squared minus 10x minus 3 all squared to be equal to 9 minus 3x all squared. So square can cancel square root. If that is taken, then I can, if that's taken, then we are left with 8x squared minus 10x minus 3 to be equal to, when I open up this, I have 9 minus 3x into bracket 9 minus 3x. 9 times 1 is 81. 9 times 1 is 81. 9 times minus, so I'm going to have 81 minus 27x minus 27x. This also minus x minus plus 9x squared. At this point now, I can decide to bring everything to one side so that I'll be left with 0 at the other side. So, so let me bring everything to right hand side. Initially, we have 9x squared at right hand side. I can bring this in. I will have minus 8x squared. Then minus 27 minus 27, that's minus 54. I have minus 54x. By the time this comes to this side, I will have plus 10x. Then I have plus 81. This will be plus 3 equal to 0. So at the end of the day, 9 minus 8 is x squared minus 44x plus 84 equals 0. So this is a quadratic equation. I'll have it 4. Okay. The two factors will now be x squared minus 42x minus 2x plus 84 equals 0. I can do the grouping. So x is common. So I'm going to have x minus 42. Minus 2 is common. I'm going to have x minus 42 equals 0. So from here now, I can group these two to have x minus 2 into bracket x minus 42 equals 0. This simply means that x minus 2 equals 0 or x minus 42 equals 0. So x is equal to 2 or 42. And these are the two values of x that we have. But most of the time, it's only one value that can be valid. If you look at the question now, look at the given question. If we picked 42 as value of as x equal to 42, we are not going to get is equal to 4 that we have the question. So in this case now, we choose s is equal to 2. So why do we choose s equal to 2? Let me just quickly tell us from the question. This is the question. Square root of 4x plus 1 plus square root of 2x minus 3 is equal to 4. So if you substitute the value of x into this now, we should be able to get 4. Look at when x equal to 2, what happened? We have square root of 4 times 2 plus 1 plus square root of 2 times 2 minus 1 and minus 3. 4 times 2 is 8 plus 1, 9. Square root of 9 is 3 plus 2 times 2 is 4. 4 minus 3, 1. Square root of 1 is 1. We are able to get 4. But if we put 42 there, 4 times 42, that is 168 plus 1, 169, that is 13. Even 13 alone is more than 4. So the right answer to choose is when x is equal to 2. So when x equal to 2 is the right answer that we are expected to choose. So I will take one more question, one more example under this. Then I will conclude the class on math sort. So another example, let's say example 8, where we have solve square root of x plus 5 plus square root of x is equal to 5. So this is the last example. So how do we approach this? Still the same thing. Solution. In this case now, we first take the square of both sides plus square root of x. We take the square of both sides is equal to 5 squared. So if I expand this now, I'm going to have square root of 5, x plus 5 plus square root of x multiplying square root of x plus 5 plus square root of x is equal to 25. That's what I'm going to get. This times this, I'm going to have x plus 5. Then plus this times this will be x into bracket x plus 5 square root. If I use this to multiply this also, I'm going to get 2 of this. Then this times this is going to give me x is equal to 25. So what do we do here? I'm going to have x plus s is 2x. Then I'm going to have 2x plus 5 plus 2 square root of x into x plus 5 is equal to 25. That's what I'm going to get. And if that is the case, what do I do here? I want to transfer every other thing to the other side. I'm left with 2 square root of x squared plus 5x. Yeah, when I open up what I have here, to be equal to this 25. By the time this 5 cross this correct side, I'm going to have 25 minus 5 minus 2x. Of course, this is 20 minus 2x. Then 2 can come out. From here now, 2 can come out. I can bring out 2 to have 10 minus x. That's what I'm going to have in the upper bracket. Then this same thing as 2 square root of x squared minus 5x, no, plus 5x. Divide both sides by 2. 2 will take care of this. This will take care of this. At the end of the day, we are going to get, we're left with square root of x squared plus 5x to be equal to 10 minus x. So at this point now, for me to be able to remove this square, I'm going to take the square root. I'm going to take the square. Now take the square of both sides. So if I do that, if I take the square of both sides, I'm going to have square root of x squared plus 5x all squared to be equal to 10 minus x squared. And this same thing as 10 minus x into bracket 10 minus s. This is what you get. So this we cancel this so that we are left with x squared plus 5x to be equal to 10 times 10 is 100 minus 10x minus 10, that's minus 20x, then plus s squared. That's what we have. So if I decide to bring everything, I can decide to bring from there now. We know that we have s squared here minus s squared. If this should come in, I have plus 5x here minus 20, that will be plus 20x. It's got to 100 here because I can see that this will take care of this. That will take care of this. 5 plus 20, that's 25x is equal to 100. So we are going to get just one value for here, for x. 25 divided by 25. This will cancel this. Then I have x is equal to 4. So what we have here is that x is equal to 4. X has only one value. So can we, if x is equal to 4, can we check? Let's just check if our answer is right. Check. What is the question? Square root of x plus 5 plus square root of x is equal to 5. Let's check if what we have done is correct. Then from here, when x is equal to 4, I'm going to have square root of 4 plus 5 plus square root of 4. 4 plus 5 is 9. So I'm going to have square root of 9 plus square root of 4. Square root of 9 is 3 plus square root of 4 is 2. Then it is 5. So we are very correct. So we are correct. So, ladies and gentlemen, I would love to stop the class. So if you have any question, you have further questions, or you need more explanation is needed on mastering salt, you can just put it in the comment section. Or if you have any question that you are unable to solve, just put it in the comment section. I will attend to it. I promise to attend to it. So thank you for your time. Thank you for listening. Bye.